Dear students, greetings for the day. In this class, we shall know about simple harmonic motion conditions and definition of simple harmonic motion, examples of simple harmonic motion and equations of SHM. We know that motion is three types. When the position of the body changes with respect to time and surroundings, then it is said to be in motion. This motion of the body is three types. One is linear motion or translatory motion. When the body is moving along the straight line, then its motion is said to be linear motion or translatory motion. Second one is rotatory motion or angular motion. When the body rotates about a point, then it is said to be rotatory motion or circular motion or angular motion. Third one is oscillatory motion. So in this chapter we shall discuss about the oscillatory motion. So this oscillatory motion is the particular case or special case of periodic motion. A body which repeats its motion after certain time interval, then its motion is said to be periodic motion. For example, moon around the earth. For every 30 days, moon completes one revolution and it travels in the same path. So it is the example for periodic motion. Similarly, the rotation of earth around the sun is also an example of periodic motion. So therefore, the motion of the body which repeats its motion after a certain time interval is known as periodic motion. For example, the motion of the moon around the earth and the motion of the earth around the sun. That means moon repeats its motion after every 1 month. And similarly, earth completes one revolution around the sun after every 365 days. Simple harmonic motion is also represented by SHM. So this simple harmonic motion is the special case of periodic motion. When the body repeats its motion along a straight line about a mean point such that its acceleration is directed towards the mean position and is proportional to its displacement, then the body is said to be in simple harmonic motion. Therefore, simple harmonic motion is defined as the motion of a body along a straight line such that its acceleration is directed towards the mean position and is proportional to the displacement. Therefore, simple harmonic motion is defined as the motion of the body along a straight line such that its acceleration is directed towards the mean position of the body and is proportional to its displacement. If A is the acceleration and displacement is the x, then A is proportional to x. But direction is opposite to the direction of displacement. Therefore, A is proportional to minus x in this case. So, when we apply external force on the body and such that it puts the body in the periodic motion along a straight line, then some internal restoring force is produced inside the body which tries to back it to the mean position. So for example, in the case of simple pendulum, when we draw to one side and when we leave it, then it again tries to come to mean position. But when the Bob's potential energy at highest point is converting into kinetic energy, it reaches its mean position with a certain velocity, so that again it crosses the mean position and it reaches to another side and till its velocity becomes 0. Again it comes to back and repeats it and travels in the backward direction and again reaching the starting point, again it repeats its motion. So the oscillations are simple, pendulum or harmonic, simple harmonic. Now we shall write the examples for this SHM. So when we draw the cradle to one side and when we leave it, its motion continues after certain time interval. Second one is vertical oscillations of a loaded spring. So when the spring attached to the certain roof, and when we add with certain weight and when it is stretched and when we leave it, it make vertical oscillations like this. So these vertical oscillations of the loaded spring is simple harmonic. Next, oscillations of simple pendulum or simple harmonic. Next, motion of a ball on a concave surface. Next, motion of a needle in a sewing machine. Next, motion of liquid in a U-shaped tube. Vertical oscillations are motion of a liquid in U-shaped tube. Next, cork floating on water waves. So these are the some examples for simple harmonic motion. Motion of a cradle is simple harmonic. Vertical oscillations of a loaded spring when stretched and leave it, it makes vertical oscillations. Those are simple harmonic. And oscillations of a simple pendulum are also simple harmonic. Motion of a ball on a concave surface is also simple harmonic. Motion of a needle in a sewing machine is also simple harmonic. And vertical oscillations of liquid or motion of liquid in U-shaped tube is also simple harmonic. And cork floating on water waves also simple harmonic. These are some examples for SHM. Now we shall know about the conditions of simple harmonic motion. So for any motion to be a simple harmonic motion, it must satisfy certain conditions. First one, the motion of the body should be periodic. And second one, the motion of the body should be along a straight line and about its mean position. Third one, acceleration is directly proportional to its displacement. And fourth one, and its restoring force should always be directed towards the mean position. Fourth one, acceleration and displacement are opposite to each other. So motion of the body So every body should satisfy certain conditions for its motion to be simple harmonic. First one, motion of the body should be periodic. That means its motion should repeat after certain time intervals, and motion should be to and fro along a straight line. That means the body must execute the body must execute the body must execute the body must execute to and fro motion along a straight line. Third one, acceleration and displacement are opposite to each other. So acceleration of the body and displacement of the body should always opposite to each other. Acceleration is directly proportional to the displacement of the body, and restoring force should always directed towards the mean position of the body. So these are the conditions of a simple harmonic motion. Now let us show that the motion of a body along the circumference of the circle on any diameter of the circle is simple harmonic. So the circular motion of projection of a body on any diameter of the circle is SHM. Let us consider consider a circle of radius r and center be O. Consider a body which is moving along the circumference of the circle of radius R and the radius is O. Let it be initial displacement or phase at 0 time, let it be phi, and let reaches to the point A to point B in time t covering an angle omega t. So here radius vector is r bar, which is equal to OA. Here let this be x dash and y o. So the projection of a body on the diameter of the circle. Okay. This is horizontal diameter along x direction. This is vertical diameter along y direction. Now this is the called initial phase or approach. And time theta equal to 0, the displacement, angular displacement. And in time t, let it reaches to B. Then here angular displacement theta is equal to 5 omega t plus 5. Now let us consider only here phi is nearly equal to 0. So let this be wholly be as theta. So here, for example, if the body after a certain time, if it reaches its projection on horizontal diameter is this one, therefore O M, let this be x displacement from the main position. And when it reaches to the, suppose, let this be N. So like this, this moves from this place to projection, tip of the projection moves from this place to this place. And similarly, when it reaches to the point, then this tip reaches to this point, 0. And when the body moves from Y to x dash, then this tip moves projection when it is at this place, this one, and when it is here, and when it reaches x dash body, then tip also moves and meets at x dash. When the body moves to this place, this projection again comes from x dash to this place, and when it reaches to y, body reaches to y, again this tip also moves to center of the circle 0, and when it reaches to the starting point, then again tip moves to same starting point A. So body after completing first half, the tip also moves from the A to x dash. Similarly, when it completes second half rotation, the tip also moves from x dash to O when it comes to y, and again after completing one revolution, again it comes to the same starting point A. So after that again certain time interval, again it repeats its motion in the anti-clockwise direction from A to Y, Y to X dash to Y, Y to A. At the same time, tip also moves from A to O to X dash to O, and O to A. So like this, the tip also completes one oscillation, two motion and one fro motion. So one to and fro motion completes one oscillation. So tip also completes one oscillation along the horizontal diameter. Similarly, when we consider its motion along vertical diameter, then when the body is at A, its projection is at O, and when it reaches to B, then it reaches to this part, that is the N, and when it reaches to Y, then tip also moves from 0 to Y, and projection moves to Y, and when the body moves from Y to X dash, this tip moves from Y to O, and when the body moves from X dash to Y, this tip moves from Y, and when the body reaches to A, again the tip reaches to O. So after completing one revolution, again the body comes to the same O, and again it repeats its motion on the vertical diameter. So after its completing one revolution, after certain time period, that is called time period, so tip also completes one oscillation along the vertical diameter. So the motion of the projection of the body on any diameter of the circle is SHM. So here, first one, so consider the motion of a particle consider circular motion of a particle at A. Consider the projection of the circular motion of the particle at A along the circumference of the circle of radius R and center B O. First case 1, when the body considering the projection of the body on X diameter or horizontal diameter. When the body is at A, tip of projection is also at A. Consider the second case. When the body reaches to the point Y, when the particle reaches to the point Y, then tip moves from A to O, then tip of projection moves to O, center, from A to O. When the body moves from A to Y, then tip moves from A to, projection moves from A to O. When it comes to this place, projection also comes to like this. And when the body moves from this place to X dash, then tip also moves to X dash. Next, when the particle moves to or reaches to X dash, then the tip of projection reaches to another end of the horizontal diameter. Which is shown from tip moves from O to X dash when the body travels from Y to X dash, and both are coincide. Next, case D. When the body reaches to, when the particle reaches to the point Y to Y dash, or Y point Y dash, then the tip of the projection moves to O. So when the particle moves from X dash to Y dash, then tip also moves from X dash to O. Next, case E. When the particle reaches to the point A, again starting point, then the tip of the projection of the motion of the body reaches to A from O. So later, after this, after the completion of the one revolution, again it comes to the same starting point A. So after completing one revolution, the tip of projection repeats the same path AO x dash to A to O to x dash, and again x dash to O to A. Therefore, after certain interval, again it repeating the same point, and this make like oscillatory motion around the mean position. Oh, therefore, the motion of the, therefore from this about the mean position O. About the mean position O. Therefore, the projection of a particle on x diameter is simple harmonic. Therefore, we can say the projection of the particle on x diameter, the projection of circular motion of the particle on x diameter of the circle is simple harmonic. Now let us show in the case of y also. So when the body is at A on the x diameter, projection is also here. When the body reaches to B, then projection moves to this point M, and when the body moves to Y, then projection moves to from M to O, and when the body reaches to x dash from Y, then this tip moves from O to x dash, and when the body travels from x dash to y dash, then again tip moves from x dash to O, and when the body travels from y dash to A, then tip moves from O to again starting point A. So after the completion of one revolution, body again reaches to the starting point A. So tip starting point A. So again the motion of the body and the diameter projection is repeating, that is from A to O, O to x dash, and x dash to O, while the body is moving along the circular path, again O to A, and the motion repeats. Therefore, the motion of the projection of the body on the x diameter of the circle is simple harmonic. Similarly, let us prove the second case in the case of vertical diameter.